Okay, this is chapter one in statistics one. Chapter one is about just an introduction, which contains so many concepts and ideas that the student has to master and understand and practice. So the title of that one is basically says where, why, and how the data collection. So we have a few sections to cover and we have few outcomes. So we need to know the data collection methods. We need to differentiate between two things, population and sample. And we need to understand the similarities and differences between different sampling methods and understand how to categorize data by understanding or knowing the type and the level of measurements. These are the 3 or 4 most important outcomes that we are going to work on in this lecture. Okay, what is business statistics? It's a collection of procedures and techniques used to convert data into meaningful information. Why? Because we need to help the decision makers. We have raw data. We have to work with these raw data into meaningful information to give some insightful for your decision maker to make decisions. We have 2 branches of business statistics. The first one, we call it descriptive statistics. Descriptive statistics. The other one, we call it the inferential statistics. Inferential statistics. The first part is, or the first category, we're going to spend chapter 1 through 6. Actually, chapter 1 through 3, then we're going to cross the bridge using 3 chapters, chapter 4, 5, 6. Then we're going to come into the conclusion, which is the inferential statistics. So the first 3 chapters, we're going to work on the descriptive statistics. So we're going to describe data. After describing data, we're going to cross the bridge. After crossing the bridge in chapter 4, 5, 6, we're going to go to chapter 7, 8, 9, which is speaking about inferential statistics. So describing data, basically, if we just draw a picture here, or just, plan for what we're going to do, basically. First of all, the first step we're going to learn is actually how to collect data, collecting data. After we collect data, we are going to organize data. After we organize data, we are going to summarize and describe. Basically, we will do something before that. We're going to present and visualize data. We're going to see it, right? After that, we are going to describe and summarize data. Summarize data. So this is the first, stage of learning. So this covers the first 3 chapters. After this, we are going to do what? We are going to move to the bridge. This bridge will contain establishing kind of a background about probabilities, which contains chapter 4. Chapter 5 and 6, we'll be talking about distributions. Then we are going to move to the inferential statistics, which is basically the 5th, let's say, step, which is doing an estimation. Number 6, we're going to do hypothesis testing. Everything we have done at the beginning is going to be do some analysis about samples, because actually we cannot, access the whole population, and in most of the cases we cannot access the population. So what we are going to do, we are going to work in samples, collect data, organize data, then present them, visualize, and describe them. After that, we're going to tell a story about the whole population. So can we take these data and go from here to the estimation and hypothesis testing? Can we estimate the population mean, for example? Can we tell something? For example, if you have a sample of like 100 people out of thousands, and you find that the average of their, let's say suppose we're talking about the grades, right? And the grades in statistics class, we just sample 100 students out of thousands in universities across the US, and the average was, let's say, 75%. Is that something that we can tell about the population or no? So this is chapter 5 and 6. And this is an example about textbooks and the publications. For example, if you look at these data, we have books and units sold, pages, books, competing books, advertising budget, age of author. This is kind of a data, raw data, right? We can organize these. These are organized in a table, which is really good. After we organize them, we can present them, we can look at them, basically. We can make some descriptive statistics about them. We can describe data. We can tell something here about the sample that we collected, right? This is kind of one example. And we can find the mean of the books that have been sold, the mean or the average, let's say, of cost or revenue or budgeting or the age of the author. We can find I mean, the most frequent market classification, let's say business or social sciences or something. So we can do some descriptive here, right? After that, we can do some estimation and hypothesis testing about the population. We're going to speak about this later. So procedures for collecting data, we have many procedures to collect data. We can do experiments, we can do telephone surveys, we can do written questionnaires or online surveys, we can do observations, or we can do interviews, right? All of these are valid procedures of collecting data. Experiment quickly is a process that produces a single outcome whose result cannot be predicted with certainty. It's just an experiment, right? And experimental design, a plan for performing an experiment in which the variable of interest is defined, one or more factors are unidentified to be manipulated, changed, or observed, so that the impact or the influence of the variable of interest can be measured or observed. Experimental design, we do sometimes use experimental design. This is an example. I'm not going to go over this one. The other type of collecting data is telephone surveys. It was really popular in the past, before the era of the internet and having that booming in the internet technology. So in the past, people used to call phones and to ask people or respondents or subjects or human subjects about something and ask them a few questions. Some of the questions are closed-ended questions like yes or no, multiple choice, or something like this. Some of them are open-ended questions. For example, tell me what you think about this, and people start talking about things, right? So sometimes you have closed-ended questions or open-ended questions in these telephone surveys. So if you just look at the steps, how do we do the telephone surveys? The most important, I mean, this is kind of a generic kind of steps. First of all, you have to know the issue. What do you talk about? What's your goal? What's the question that you will be asking, right? After that, you have to define your population of interest. Population of interest. Are you talking about, for example, people? Are you talking about vehicles? Your population is going to be colors, preferences of food. Let's say, what is the population? The population is not necessarily to be human subject. This could be any other kind of objects, right? After that, you develop the survey questions, open-ended, closed-ended questions. Then you pre-test the survey. You just give it to a few people to check whether would you like to add or eliminate some of the questions. After that, we determine the sample size. So how many people you would like to survey, because you can't, for example, if you'd like to survey, suppose, people who owns American vehicles or Ford, let's say. So you cannot access every individual in the US who owns Ford. So what you're going to do, you're going to sample. You're going to say, hey, I'm going to pick 100 sample. Then you're going to decide the sampling method, how you are going to pick these 100 people, right? After that, you select the sample and you start making the calls and asking these questions. When you do the surveys, usually you have the questions. After that, you have the demographics questions, which is something that important that we need to do. Demographics questions, we're asking people about their gender, income level, education level, marital status, maybe social, economic, status, etc. All of these. It depends on what you exactly would like to do with these data. The other type of collecting data is written questionnaires and surveys. Written questionnaires and surveys. This is common right now, especially the online ones. And one of the common tools, people use is SurveyMonkey, is one of the, well-known website. And again, you can ask people two types of questions, open-ended and closed-ended questions. The open-ended question gives people more flexible way to answer questions. However, it's hard to analyze. It's more difficult to analyze these kind of, because people write their own. Suppose you are, let's say, sampling 100 and the 100 people are, and you ask them two open-ended questions and everyone, what is your perception about this? What do you believe about that one? Do you agree with this and why? So people are just writing down their beliefs or their perceptions or their emotions or their feelings. Then this is kind of hard to analyze basically compared to the closed-ended, because the count, closed-ended, yes, no, or agree, disagree, strongly agree, etc. Okay. Almost we have the same steps. We have to know the issue first. We have to know the population, and we have to design the survey very well. After that, the pre-testing, we have to implement this into small group of people. After that, we have to get the sample size, sampling method. After that, sending surveys. Hopefully, you're going to get some of the responses. It's one of the advantages. It's low cost, effective, because you don't pay that much money. Actually, you just pay, for example, if you do it on a monthly survey, or you just pay, I don't know, a couple of $100 or something. And it gives you the chance to send the link to 1,000 or whatever, I don't know. So it's not expensive. You can reach so many people in different, in a big demographic, in actually everywhere, so it's low cost, effective of collecting data if you do the online, especially the online surveys. But we have problems with this. We have actually two problems with this. Number one is having leading questions. Actually, when you do written questionnaire or online survey, leading questions is one of the mistakes that people do. So when you write the questions, they have to be neutral. You cannot have a question that has, that leading the respondents to answer in a certain way. You're kind of guiding them to answer in a certain way, which is something wrong. So what you have to do, for example, do you agree with most other reasonably minded people that the city should spend more money on neighborhood parks? We have two problems here. First of all, you ask them whether do they agree? Do they agree? actually, this suggests that they should agree, right? They should agree. I mean, because do you agree? Yeah, actually, you do agree. This is a leading kind of part. The other part that is really leading is that you're telling them that, oh, other reasonably minded people. So what you're telling them here that, oh, so I have to agree because I will be considered as a reasonably minded people, part of this group. Because if I said no, I will be considered none of these reasonably minded people. So these are two parts that seems to be, oh, it's bad actually. So we have to paraphrase that question. We can ask how? We can ask, in your opinion, should the city increase spending on neighborhood parks? Very simple, very straightforward, without biasing in terms of, we don't guide them into a way or another. Again, in your opinion, should the city increase spending on neighborhood parks? There's an improvement of that question. The other problem is what? Having poorly worded questions. How much money do you make at your current job? And actually, I've been facing these questions so many times. What do you mean? Hourly, yearly, monthly, permanent job? What kind of things you're asking? This is inconsistent. People, they're going to give you different answers. Some of them are going to tell you that, hey, I'm paid $20 per hour. The other is going to be, so this is hard to analyze. So maybe what you can do is improving by putting categories, like which of the following categories best reflect your weekly income from your current job, and you give them categories like under $500, between $500 to $1,000, over $1,000, and let them choose. Then you can analyze your data well, and you can get consistent data. Other types of collecting data is direct observation, which is another procedure that we use it to collect data, and it's observing. It's just observing, sometimes recording, right? And the last one is going to be the personal interviews. Personal interviews, when you interview people, you ask them open-ended or closed-ended questions. It depends on the question that you ask. A pre-prepared list of the questions, or you just have the theme, the general theme, where you ask them and they start talking, and you have a follow-up questions, etc. So we divide the interviews into two types, basically, or three types, in some texts. The first one we call it structured interviews. The other one we call the unstructured interview. The structured interview, if you have questions already written down and you just read the questions and they start answering. So these are pre-prepared questions. We have a list of questions before. The unstructured, you have the general theme or the broad stated questions. Then you ask further questions while the respondents start answering. It's kind of follow-up questions. So maybe we call it unstructured interview, or sometimes, and in some books they call it semi-structured interviews, and unstructured, they kind of categorize them in different categories, but at the end of the day we have the same concepts here. Other data collections like barcode, this is kind of when you do products or something. Issues with data collection, which is something that we need to consider, something we have to consider. The first issue sometimes we face is the data accuracy. For example, when you need data to make a decision, we suggest that you first see if appropriate data have already been collected or not, because it's usually faster and less expensive to use existing data than to collect data yourself, right? But before you're relying on such data, you have to make sure that these data will serve you well. So you have to check the source of the data as well, and whether the data were recorded correctly or no, or accurately or no. So this is one of the things. The other thing that we have to look at is the biases, which is a big issue when we're collecting data. What is the bias? The bias is an effect that alters a statistical result by systematically distorting it, different from a random error, which may distort on any one occasion but balances out on the average. This is the bias. So you have many types of biases. First one is the interviewer biases. How is this? How this happens? The way that you ask questions, the tone of your voice, or the way you look to the respondents. So it's kind of, you're telling them to answer that way. And maybe you're going to ask them the question again. Are you sure that are you happy with your answers? Would you like to change your answers? It's kind of, you're telling them, hey, change your answer, please. So this is what we call it, interviewer bias. This will give you biased data. The other one is the non-response bias. Non-response bias is actually when you send, for example, the survey to 100 people, and suppose that these people are male and females, or let's say poor and rich, and the ones who responded to you are the rich ones. So it's a non-response bias because the other part of people, or the other demographics of people did not respond. Or sometimes you sent it to 1,000 and you got an answer just from 50, right? So this is a non-response bias because sometimes you get answers from a group of people and you do not get response from the other group of people. So you'll have a dominant kind of groups who will, when you analyze your data, you're going to get like a dominant point of view, basically. The other one, we call it selection bias. For example, if you do a telephone survey during the evening hours, let's say, so now you are excluding the morning people. Or if you are conducting your survey or your observation on the 8 to 9 classroom students, you go and observe them. What about other classrooms, 12 to 1 or the evening classes. So this is kind of selection bias. This is kind of what a selection bias. The last one is the observer bias. It's sometimes we collect data through personal observation. So the subject, this could be a problem. I mean, people tend to view the same event or item differently. So that's why it's an observer bias. For example, if you observe a classroom and you feel that, or not, you see that students are distorting or distracting the class or something, and another observer came and he found no, students are actually actively motivated and work with their professor, then we have two different views here. The first one found that students are distracted and they are making noises, but the other one found no, they're actively participating. So this kind of bias, we call it observer bias. Measurement error is the thing that we did not mention. I mean, it's from the name. The measurement. If you, for example, would like to measure a piece of food and you take the measurements to the nearest centimeters or inches, others, maybe they're going to take it to the nearest millimeters. So we create kind of measurement error here, right? The other two concepts, we're going to speak about them later, maybe internal validity and external validity. And the next concept that we're going to discuss here quickly, which is the population and sampling techniques. First of all, what is the population? The population is the objects or individuals of interest. For example, you care about studying subjects. Let's say perceptions about flavor of a product. So your population is going to be people. Or suppose you are you're going to study the most common vehicles on the road and why. So your population is going to be vehicles. Or you're going to be more specific, four-wheel drive vehicles, the most purchased or cheapest or whatever one on the road. Okay, we're talking about 4x4 vehicles. Or you can study teams, football teams. Football teams, let's say you will be studying the average of salaries, right? So in football teams, so this is your population. So the population, it depends. Sometimes it's an object, it's an individual, etc. The sample is the population. The sample is a subset. You just take a subset of this because you cannot access the population. This is important. You cannot access the population. Then you take a sample, right? It's less expensive. It's not time consuming compared to the other one, right? So that's why we take a sample. The question is, the sample, is it representative or no? This is a big question, right? So we'll be answering these. If you take a sample and you find the mean of the salaries, is that representing the whole population or no? This question will be answered in chapter 7 and 8 and 9, or 8 and 9 basically, right? Census is an enumeration of the entire set of measurements taken from the whole population, right? Just a count, you just count them. Sampling techniques, we have two types of sampling techniques. We have the non-statistical sampling techniques, we call them non-probability sampling techniques, or statistical sampling techniques. Non-statistical sampling techniques is more common. For example, if you are in your classroom, you have 20 students, suppose you're taking a class, statistics one, and you'd like to measure their perception about, let's say, about their favorite sport, right? Let's say favorite sport or something like this. So, and you're going to ask them some questions, right? And your population is going to be, suppose that is the whole, let's say the whole population, all American citizens, everyone lives in America, but you can't access them. So what you do, you just pick some of the students in your classroom and your friends, your neighbors, etc. Then you start asking them questions or sending them the link. So in this case, you're using what we call convenience. This is a convenience sampling method. It's a convenience sampling method, which is, it's non-statistical sampling techniques because you use that one because it's easy to get to the sample, right? This is a very common method. The other type, we call it statistical sampling techniques, which basically it has another name, which is a probability sampling technique. This is advantages because you give every individual in the population a chance of being in the sample. The other one you don't give. The non-statistical sampling techniques, you don't give the chance to everyone because you have chosen people based on your convenience, right? Because they're easy to reach. So you don't give anyone in the population the same chance of being selected. But in the statistical sampling technique, you almost give everyone the same known chance of being included in that sample, right? And we have the simple random sample, stratified, systematic, cluster sampling, random samples. All of these are techniques. We use them to do statistical sampling. The easiest and fastest one is the simple random sample. You have a population, for example, you have a list of students, list of whatever. You have the list, like thousands of people. You start picking them randomly based on, for example, you're rolling the die, you rolling the coin, or throwing the coin, or maybe you use a number generator in Excel. Then you just number one, you just give them numbers. People, you just enumerate them. 1, 2, 3, 4, 5. Then you start, for example, using the generator in Excel, random number generator. Excel give you etc. like 1, 5, 6, 6, 9, etc. Then you start picking these people, right? So this is simple random sample. The other technique we use it is the systematic random sample. Systematic random sample, you give the population numbers. I mean, you enumerate them from, let's say, 1 to 1,000. Then what you do, you start with, suppose that you have 1,000 population, and you'd like to have a 100 as a sample. So what you do, you just divide 1,000 over 100, so you're going to get 10. So first of all, you're going to start with a randomly one from 1 to 10. You're going to take simple random from the first 10, which is number 2. Suppose it's number 2. After that, you jump 10. I mean, you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then you take the other guy. Then you count another 10. In this case, we are counting 3. So we started by this guy randomly. Then we count 3. We count 3. We count 3. We pick them. We pick them. This is systematic. Every third. We take sample from every third. Okay. The starting point is always between 1 to k. 1 to k. To k is, as we said, this is the 10. This is my k. Right, which is the ratio between the population and the sample size. This is systematic. It's very close to the random, but it's kind of systematic. The other technique, we call it stratified random sampling. What do? We divide the population into stratas, groups. Okay. Normally, these groups are divided in a certain way. Then you start picking random sample from each group. For example, we divide the population into that group. Suppose that you have a big area like Michigan. In Michigan, we divide them into north, west, east, south areas. These are stratas. Then I pick, like, I decided to pick 50 from each strata. So you pick this one from here, randomly. From each strata, you pick random individual or individuals, okay? Then you create your sample. This is stratified random sampling. The other one, we call it cluster sampling. Cluster, we divide people into clusters. Okay, someone's going to tell me, what's the difference between clusters and stratas? Okay, normally, stratas are homogeneous people, like homogeneous demographics, homogeneous gender, homogeneous social status, homogeneous maybe marital status. Maybe you're going to group the married people alone and the non-married alone, right? In another strata. Maybe as we did demographics, we said the north area, the south area. So we believe these are kind of homogeneous groups: north strata, first strata; south, second strata; west, third strata, and so on. But in the clustering, it's not necessarily those people to be what? To be homogeneous. And the other thing is, when you do clustering, when you cluster the people into groups, you pick the whole cluster. You decide to pick, okay, we got 5 clusters. You're going to pick 2 clusters. We pick them randomly. So in this case, we pick these 2 clusters, right? So this is a clustering sample. So this is the difference between clustering and stratified. Look at these people. This is a homogeneous. Same kind of a group. These are non-homogeneous. So, but in this case, we pick individuals. In stratified, we pick individuals from each strata. For the cluster, we pick the whole cluster. Okay. The last topic I would like to talk about is the types of data and level of measurements. We have 2 types of data. It's very important: quantitative data and qualitative data. Quantitative data is inherently numerical. The data, the values that is taken by these variables are numerical. Weight, height, number of calls, number of customers, number of people. All of these numerical. So it's a quantitative data. The qualitative data, the scale is categorical. Categories. In nature, it's categories like marital status, married or single. These are categories. Favorite colors: white, orange, purple. These are categories. Favorite drinks: Coca-Cola, Pepsi. These are categories. Types of food or cuisines, categories. Okay, so all of these qualitative data. When you collect data, sometimes you collect them over time, so we call them time series data. Sometimes you call them at fixed point in a time, so we call them cross-sectional data. Just in a fixed time, we collect the data, or sometimes we collect data over the times. The last part we're going to talk about is the data measurement levels. We have 3 main levels. The lowest and the base one, we call it nominal data, nominal variables, which is the lowest level, the basic analysis. This contains groups, categories, ID numbers, marital status, favorite colors, favorite food, all of these nominals. The other level, we call it it's the mid-level, which is the ordinal data, the one that has ranks. For example, we give the customers 3 food cuisines to rank them. So everyone will give you a different rank. This is first, second, third. So this variable is ordinal data, ordinal variable. The highest level, which is of variables or data, that contains measurements, numbers, variables, not variables, numbers. Right? We can speak about everyone. Ratio and interval. So the nominal is the lowest one. We assign code to categories. As we said, examples: marital status, married, single, divorced, other, 1, 2, 3, 4, 5, etc. There's no specific meaning for these codes because there's no order. Doesn't matter if you put single first, married, divorced, doesn't matter. But matters in the ordinal data. When you rank the products, let's say, product number, or the winners. The winner: gold, silver, bronze. So these are ordinal data. Or the level of education, BS degree, MA degree, PhD degree, and so on. The interval data is a numeric. We have a distance. We have something intangible between the values. We have the same distance between the values. We have scales. A very important example, or actually it's kind of unique example, which is the temperature scale. The temperature. Temperature is an interval kind of variable. Why? Because when I tell you 40 Fahrenheit and 45 Fahrenheit, we know that 45 is higher than 40, and the distance between 45 and 40 is 5. So we just subtract them, so we get 5, and this makes sense. And the distances are equally spaced. Okay. The last one is the ratio, is almost similar to the interval. The only difference that the 0 point is the true 0 point in the ratio. What does it mean by the 0 point? This is, let me give you two examples. The temperature, for example, here, and the weight. If I tell you that the weight of something is 0 pound, what would you understand from this? You would understand that, 0 pound means nothing, none. Nothing, 0. It has 0, none. There's right? Or I have 0 apples. There's none. But the temperature, when I tell you that, the temperature is 0 Fahrenheit, not this Fahrenheit, it has a meaning. This one is not the true 0. This one means, it's cold, man. Super cold. Right? So that one on the left, we call, this is part of the interval variable. This is an interval variable. This is ratio. So the only difference is the true 0 point. Okay? The true 0 point. So this is kind of everything that I would like to say. This is the last example I'm going to cover. So if you look at the data here, we have an Excel, we have data, we have variables. Look at the first one, college name, nominal. It's a qualitative. Why it's a qualitative? Because just, names, right? It contains names. This is qualitative, right? It just contains name. Public, private, qualitative. Also, it's names. Okay, it's 1 and 2, but it's just names. Or you can say this is a nominal, basically, right? So the first one is a nominal, also nominal because there's no ranking, nominal. This is nominal because just names, and this is nominal as well, nominal. Everything else, math stat score, variable stat score, number of applications recorded, number of application, whatever, number of a new student, and all these numbers has, all of them numbers, they have meanings, all of these are ratios. Ratio, there is no ordinal here. Do you have something that has an order? No, ratio. And these three are nominal. And all of them, they have been taken in a certain time, so cross-sectional data. So we don't see the years like data we're collected in different years, right? So it's a nominal. It's a cross-sectional data. It's a cross-sectional data. So this is what I wanted to say about that example. It seems that, yeah, we did not say. Okay. Actually, the details of we don't have them, but that's okay. Yeah, this is everything about this chapter 1. So I'm going to pause here. So I hope now you can cover the materials related to that chapter. Thank you.